Hello. How's everybody today? Yeah, we're to some fun stuff that we're going to work with, which is GUI programming. Now, there's a lot of similarities to the way Python limits graphical user interfaces with other languages, and primarily the similarities are that it's form based. Um, It's event driven, meaning that things only happen based on when the user clicks on a button or does something within the interface itself. And that means that we need to create controls, widgets, and other things that we add to a form and place them in the form based on how they pack within the frames, and of course show it and respond to the events. Another similarity that they have that is down here at the bottom, drawing shapes with the canvas. So that a canvas is where you can actually do your own 2D games, and that's in JavaScript, Java, C Sharp, all of the super languages and higher level languages that have memory managers implement 2D graphics in one form or another through what they call the canvas. And basically, it's just a canvas for you to draw on. Now, what we're going to do today is we're going to talk about these PowerPoints, and then I'm going to discuss an example program. We're going to kind of walk through it, and then we're going to have some fun. Uh, we're gonna start doing a little bit on how you can actually do the beginnings of a 2D game, and we'll see how we'll continue with it into next week, of course, and we'll see. We'll get to a good stopping point today, and then we'll implement some objects into it, and hey, we'll get to the point where you got a good feel for it. We won't delve too deep inside of it though. So let's talk about the normal user interface that we are learning about, and that is uh, Tkinter, and that's the some people pronounce it Tkinter, uh, but the proper pronunciation from IT people that use it in data science, etc., is Tkinter, um, and that is a object oriented or an object based, excuse me, module that we can use for a graphical user interface. One of the other similarities that this user interface has that all other user interfaces have, and the way that things are done even in the command line, is how information is given and sent or shown to the user. So you always get information from the user as a string. Now, if you enter a number, then you have to convert that string to a number, just like you do in your command line programming. And then vice versa. Everything that goes out to the user has to be converted back to a string. So if you're going to show a label with a number in it, that number needs to be converted to a string before it can be assigned to the label's value. So let's go ahead and get into this a little bit with the graphical, or with the PowerPoint, and then we're going to take a walkthrough, uh, a walkthrough of an example program, one that you will see sort of close to one of your programming assignments. And then we're gonna get into having some fun, and then I'm gonna give you an alternate assignment that you can do. So if you follow along with this video, when we get to actually writing some code, that's gonna be where you're gonna get your alternate assignment from what's in the book. and I'm probably going to throw in some extra credit just for fun. So, all right, user interface. Something the user interacts with most often, event driven. It's similar to command line interface that the input and the output comes to and from as a string. Uh, and then that's pretty much the biggest point of it. The graphical user interface code base that we're using is object based. So whenever we create a label, we have to instantiate it using the object. So essentially, we really needed to cover objects before we could get to this point, because it is object based. One thing that most user interface gives us is the ability to have dialog boxes to simply, pop up messages and whatnot. And you can use this Tkinter to create your own dialog boxes or your own applications. There are some pre-built dialog boxes that you can use as part of it. One of them is just a simple message dialog box that is already done for you that you can implement. And of course, you can implement your own dialog boxes. So the graphical user interface is different from a command line is because it's not entirely top-down programming. It's event-driven programming. However, you still want to have the habit of defining things above and using them below. That's one of my pet peeves, even though you don't really need to in Python because the interpreter goes through your code twice. One to look for when you call a function that's defined underneath it, and one to actually interpret the code. And the event-driven programming environment is not as literal or as hard coded, I guess, to work with that top-down behavior because it is event driven. So essentially, you create a button and you assign a function that runs when that button is clicked. And then that function you declare inside of the object that represents your user interface. So we can create some simple GUIs with Python and the Tkinter module. And another term that we use inside of or with Python and Tkinter is the widget term. And the widget is any kind of graphical element. It could be anything that you can interact with or view. So a label, a text box, any of that nature. So here's some examples of some widgets. The canvas widget we're going to be playing with today, we're going to be looking at, an example where a button is used. Mostly, the check button, the list box, those are all specially designed graphical or widgets so that you can solve problems of data entry by design. It's often easier to give a user a list to select from than to have them type in what they are selecting. Because if they type it in, there's a lot more capability for the user to typo. An error will then occur. But if it's just a list box where they click on a menu option, that solves a lot of problems by design right off the bat. And that's why we use graphical user interfaces because they're just friendlier than command line programs to interact with because they're intuitive. And that's what you want to kind of keep in mind when you're designing a user interface. Now, Tkinter is somewhat limited, but it gives you the basics of what you really need to implement some kind of GUI for just a little bit more sophistication of your scripts. If you want to give that to members within a group or an institution or that you're working within instead of the command line. So here's the thing about the graphical user approach and Tkinter. If you are running it from idle's always kind of waiting for a prompt. So the idea of event-driven programs does not really work with idle. And in fact, I've already hopefully gotten you out of the habit of using idle. We started working on that at the very beginning, or sometime in CS 102. You should have gotten, well, you probably started in idle, but at this point, you should not be in idle. And so it's kind of a mute point. All right, so the label widget, what we need to do is when we create a label, we've got to give it several arguments. One of those is, hey, where is the label going to go? So we assign it to a window that is another object that you create as part of your program. And then, of course, you're going to assign the text that the label shows. The pack method is where we are putting it within the main window. And so we can put it on the top, the left, the right, and the pack method will always work depending on where you put it and what you packed first. So if you put two items at the top, the first item that you put at the top goes first and the second item goes underneath it. If you put two items on the left, the first item goes to the left, top, bottom. The second item goes. So it's all about the order in which you pack your items when you declare with the pack statement. All right, so here is a simple example. A frame widget is a way that we can arrange widgets in different regions of your main window. So you can have a top left frame that you pack different widgets in at the top, the left, the right. You can have another frame over here where you put different widgets in at the top, left, or right. So you can have different regions, and then inside of those areas, you can have different areas for your widgets. And remember, a widget is any kind of label, text box, list box, a button, any of those items. So frame is kind of like a mini main window. So you have your main window and you can have frames in there in different regions where you put stuff. So here's an example of frames. So you can have a top frame, a bottom frame, and then you can have different items in different areas of the frame based on how you pack them. All right, now here's one of the main things where the event-driven part of your code comes in. Most events happen based on a button click. Now you can have other events happen based on different behaviors within Tkinter, and it almost always is when the user does something. It's either a key press on a widget, it's clicking on a widget, and the widget can also be the main window. And then all the items inside the main window. And so when we create events, we need to have what's called a callback function. And that's the function that runs when the event actually happens. Now here's an example of a dialog box that's pre-built for you to use. It's a message box that you can show info. Now we're going to actually, we'll probably come back to that and play with it in a little bit based on our demo. And actually, we're kind of there. We're going to have a quit button that you don't necessarily. It's good to have one so that it destroys the object and everything that's inside from the memory pool or the memory pool. The garbage collector will be called essentially to destroy that memory. All right. So one other thing about your widgets is one that we call entry widget, this is what I refer to as a text box. And here's an example of a text box. Enter a distance in kilometers. We enter in the numbers 1000. Then we convert it with a message box that pops up. We use the message box dialog that pops up with the result. And then we quit the application with the quit button. And then here's another thing. Instead of having a output that comes up with a dialog box, what we could do is we could have a label that we put like right down here that changes with the value that we want to output instead of popping up a window. So that's where we can have a label that we only assign a value when the user actually enters something to convert, when they hit the convert button. All right, a lot of the when we are assigning the text to a label, we are using a string var object. That is essentially a superstring. So think of it just like a string, except for it's an object that's specially built to hold ASCII code characters and work within Tkinter. So string var is a string, but it's a special string for use within Tkinter. And we can create the string and assign it to a label dynamically. Okay, we've got some other stuff about some different, ints. Int var is the same thing that can be used for radio buttons. So you will have some specific data types that we use, such as int var, string var, instead of our normal primitive data types in Python that are built to work with the controls that Tkinter supports. All right, because I'm really kind of ready to move on. We've got int var again for checkboxes. Now we're getting into Canvas. This is where I really wanted to spend some time. So before we get into this, because we're gonna start building kind of a bouncing ball program, and we're gonna assign physics and gravity to it. We're gonna have some fun, and then I'm going to give you your extra credit extension or your assignment extension, and I will add an extra credit challenge to it that'll be posted in your assignment page. So let's go ahead and do a walkthrough on an example program from your book and just discuss it real quick, line by line. Look at how it processes. We may kind of delve into it and play with things a little bit. We'll see. So I'll be back shortly. See you guys soon. Okay, we are back. I brought up the kilo converter 2.py from your example files from your book, and we're going to go ahead and walk through this. First thing that we need to do is we need to import the Tkinter library, and that is part of Python. And then, since this is all object-based, even your program itself should be an object. So everything happens inside of an object. Your whole graphical user interface is part of that object. So the first thing we do is we define an object, and then we're going to come back to this definition, but let's look at instantiation. Your runtime does not start until all the way down here. That's when actually the program starts. This is just definition code. It defines what's there. And this is your runtime code. This is what actually happens. And then the object is instantiated. It draws itself. The main window pops up. and then it waits for an event. Now the event is created with the button. So if you look here, we have a calc button, uh, definition. And you see here that we send it the text of how it's going, what's going to be displayed in the button, and we tell it what frame it's going to be stored in, and we'll get to that in a little bit. But here's where the magic happens. Right there is where we tell it what function to run when the event is fired. And since this is driving me nuts, I don't like that converts down here. I would rather have convert above where we actually call it or use it. So I would actually have this all the way up here. Now you notice that convert is part of the kilo converter definition. Let's just make sure I didn't ruin this thing. Okay, there it is. So let's get into a little bit more of what this object has. And this is your runtime code for that's inside the object where you actually process. And you get the information from your entry box, which is declared here as part of your object. And this is where you say get the information. Then you take that information, you convert it to a floating point, because when you get it, it comes in as a string. Then you convert it to a float. Then you can process it, and then you can assign a value to the value variable. So let's go ahead and look at what else we have here in the init. We have the actual object definition. This is what defines the main window, and this is what we actually fill or we add our events and all our widgets to. Now, the first thing that we want to do before we add widgets is if we want to have some frames for different regions. And so we have a top frame, a mid frame, and a bottom frame. Now let's go ahead and just look at those frames. Here's the application. So this is going to be the top frame. This is the middle frame. This is the bottom frame. And then we instantiate those frame definitions with the frame object. Now we haven't packed the frames into the main window. So we pack the frames into the main window, then we pack the widgets into the frames. So then now we're ready to create our widgets to pack into our frames in our main window. So what we want is we want to have a, and when I say pack, that also happens when you instantiate. So now when we instantiate this label, we're going to tell it where it goes. We're going to tell it what's the prompt. And then the same thing, this is the entry that we're going to use. And notice that we're using the self dot, which makes this global for the whole object. And since convert is a function that is part of the object, it has access to self dot value. So, or not self dot value, but we will have the value down here. Excuse me. So every object that you create or you define in here, you have object access to up here. Now we have a prompt that we are, or a label that we're going to create, and an entry prompt that we're going to create. We're going to declare those that they go to the left hand side. So when we say pack, we say whatever container it goes into, it goes to the left side. So we declare our prompt label and our prompt entry box, our text box entry, to be on the left hand side of whatever container we add it to. Then we declare a description label that goes to the middle frame, and we tell it what it actually is described, or what the description is. So let's look at this in terms of the graphical user interface. Let me run this guy, and why are you not running? Oh, because you're right there. You're already running. Okay. So the prompt for the label, the prompt label, that's this guy right here. And you see that we packed it to the left. So and this one we packed to the left, but since they're going both in the top frame, they're going to be left adjusted. And since we put this one in first, the next one we put in, even though we say go to the left, it's going to be right here. So the prompt label is there. The kilo entry label or text box entry is here. Then we're going to have a description label. Now you notice here that this is in the mid frame. The prompt label and the text box entry, we put it in the top frame, and we packed it to the left, pack it to the left, pack it to the left. So it goes to the left. This is the second one that goes to the left of right directly next to this one. If we wanted it, if we said pack to the right, then it would right justify, and when we resize this, it would stick. But we've got these all, working in this manner. So you're going to want to play around with how you pack things and how you put things in a frame, and then look at behavior, because we look at this one and the behavior where these guys are in the top frame, but in the middle, but they're together because we packed this one to the left and this one to the left. And now, imagine if we look at this and we do a border around our frame only goes out this wide. And that's why the pack to the left stays there. So our frame is going to be basically for the whole form is in the middle. It's middle justified. So not only does it matter where you put your frame, because the frame and the widgets that you put in the frame will only be packed and placed into that frame based on how, or will only be placed into that frame based on how you pack them. And then the frame, depends on the way that you default it. When you add a frame into a form, it's going to default to the middle. Okay, and then the next thing we have here, well, let's go back to this guy, minimize it so that we can see it with a little bit more clarity. Mid-frame, that's this description label, mid-frame, and it's going to default to the middle. And then we have a value that we create as a string var. Then we have a miles label that's going to be in the mid frame, and it's going to be a self.value. So here's what's going to end up happening. This miles label, we're going to assign to the self.value. So basically what this is self.value is a dynamic string. And that's why we give it the string var value, or we instantiate it as a string var so that we can dynamically assign the miles label to the self.value that we're going to get from the user, or we're going to process in the convert function. So when I enter a value and I say convert, the convert runs, it assigns self.value, and then self.value, once it's assigned, it shows in the miles label. And basically that's kind of a hard linkage, and it works automatically for us with Python. Other languages you would have to be a little bit more specific for. You just have to link it, and then it'll work automatically. Now we get into our actual event handler. And our event handler, we call the convert function when it's clicked on, and we add a quit button to destroy the main window so that the garbage collection happens instantly, and the program is stopped. Finally, we add the buttons, how they're justified within their frame to the left. And remember, the frame is middle justified within the form by default. And then we add the top frame. We pack it into the window, the main window. We pack the middle frame into the main window. We pack the bottom frame into the main window. So we create our frames. Let's go ahead and bring up the whiteboard. And let's get, we kind of walk through this code, but let's do just a quick drawing run through on what's happening. All right. Right there, line 25 is when we have our main window instantiated. Then we instantiate a frame, but it's not been packed yet. So our frame is kind of floating out here. That's our top frame. That's our top. This is our frame that's in the middle. And then our bottom frame here. Then we create a label that we instantiate. We link to the top frame. And we have an entry, a text box entry that we link to the top frame. Then we take that label and we tell it to pack itself into the top frame, left justified. And we take the text box entry and we tell it to pack itself into the top frame, left justified. So that's where the linkage happens for where the label is going to be packing itself. So we tell it, basically the prompt goes here, left justified inside the frame. That's what's important here, guys, is that we are doing, oh my goodness, this is horrible scribbling. Prompt, and then the left justified text box entry. It all justifies to the left within the top frame. Then we have our description, and we are going to say converted to and that's our label, and this is where we're going to have our output. And we assign it to the middle frame, but we're going to pack it. We're going to pack it down here to the left. So that does this, and then we pack the description label and the miles label to the left here as well. Now this value variable is what we create to assign to the miles label. So that's going to actually be output right here inside of our middle frame on that label. And we do that because this label can only hold string var objects. We can only assign it to a string var object, but it's just a string that's been tied and is part of the library so that you can assign that string that you create, and you assign the value so that the string that you assign to value is shown in the miles label that we've packed in the middle frame to the left after this label that we packed to the left in the middle frame. Then the next bit is we create the calculate button. And it's not packed yet, but I'm just going to put it here because this is where it's going. This is the calculate button. And then the quit button. We instantiate those, assign them to the frame, tie them to the frame that they belong in. And then we tell it what function to run. We tell it to run the convert function, the one that we defined up here. And then this one, the quit button, we just tell it to run the destroy function that's already been built, that's already part of the library. So this is a function that's already been defined that's part of the main window. And that main window is created up here. And we just run the destroy function just like this convert function is run when the quit button is pressed. And then here's the final thing. We take and we put the top frame, we pack it by default, and it defaults to the middle top. Because you see here that we're not actually telling it how to pack. And then inside of here is our stuff that we have in the frames, and then it shows here in the middle top of the main window. And that's what these lines do. Now this very last line, why do they call it main loop? Well, because here's what the Tkinter object is doing. It's continually redrawing this window and this text input every probably, I would say, 5 milliseconds or so. And every time I move it, it's redrawing everything inside of it. And it's continually running that redraw and drawing these labels for us and drawing the values that we've tied to those labels with this code. And that's what the main loop is doing, is it's just continuing to redraw, but it's also doing something else. It's listening for an event. So it's just running over and over and over again. Redraw, 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 redraw. Does an event happen? Does an event happen? Redraw. Does an event happen? Redraw. Does an event happen? Redraw, redraw, redraw. No event has happened. Keep redrawing. Then we click on it. And during its redraw, it says, oh, an event happened. Well, what event happened? This button got clicked, convert. Well, what do I need to do? Well, I need to run the convert function. And so if we set a breakpoint up here, we can actually intercept that. So I'm going to click convert. Oh, it does not like breakpoints. Interesting. I must not have my debugger set up to do it. Okay. That's all right. When this convert button runs, it sets the value variable that we've created, and we've tied this value variable to the label. So this is the run through on how this stuff behaves. Now what we're going to do is when I come back, we're going to have some fun. Now, what I would kind of say is you can get down into the weeds on Tkinter as much as you want on designing a graphical user interface. But really, Python is, you will want to have scripts that you create a user interface with. You can build games. And if a lot of stuff is happening behind the scenes that you don't see within this Tkinter library. And really just use it. That's, how it's implemented. We don't really care as much. We just want to use it. So get your examples, play around with it. Remember that you assign, when you create widgets, you need to put them in the main window, either inside of frames, or the frames go in the middle main window, or you can just throw anything in the main window. And then if you need any user input and output, you tie those two labels using the string var, and then the other one is the int var. If you need to have a specific numerical value that works with like a checkbox and some of those other widgets. So the int var and the string var are what you use for that simplified user input and output information to the GUI. This is a very limited graphical user interface, and it's more to get your feet wet. What I'm going to show you with Canvas is a little bit more aligned to other programming languages and how they implement user interfaces. Like Java, C#, JavaScript uses Canvas, but their user interface is working with the HTML elements instead of widgets. But don't go down the rabbit hole too far on Python graphical user interfaces. Get your feet wet. After that, most of what you're going to be doing, especially if you're in cybersecurity, is working with command line text-driven applications. However, if you do have a user base of your scripts, or you want to make your scripts a little bit more user-friendly, this is an excellent library to use. There's others out there that you can use instead of this. But hey, have fun with it. Play around with it. A lot of the concepts that are introduced here directly relate to other programming languages that you may see. So now that we've had our run through, I want to just see if we can actually get this. And it's interesting that, maybe, you know what? That's why. See if we can actually debug. Oh, there we go. Okay. Let's see if we can't get this convert button to kick off for us, because I got busy and forgot that I wasn't even running in debug mode. So let's set our breakpoint here. Let's run this, start debug, and let's do a step over, because once we instantiate this object, it's going to create our main window and show it. And our main window is up here. Now, if this is working appropriately, we should be able to intercept when this convert button is clicked. Beautiful. Okay, that's what I was working towards. And then we can see kind of behind the scenes of what's going on. And you guys can get more of an idea of how this whole thing comes to work together as an ecosystem and how it behaves. All right, guys, that's a good overview. Let's go ahead and here is the next thing we're going to do. We're going to have some fun. We're going to actually start doing like a 2D game. And next week I'm going to continue on with this. We're not going to go all the way 2D game. I'm going to decide next week how far we go. And maybe, I really would like to do a few things. We'll see. Uh, but yeah, I'll be back and we'll start working on Canvas and start drawing things and making them bounce around on the screen. And then, of course, we'll get an extension for your assignment, and then you will see extra credit added in the module. See you guys soon. All right, and we are back. What we're going to do is we're going to talk about the canvas, and then we're going to implement it with some fun. The canvas widget is just like other programming languages that kind of it's the same as pretty much it is the same as every other high level programming language. And in the way that the X and Y coordinates work when you're drawing in the canvas. So you can work with the canvas as just basically a square rectangle that's blank and you can draw to, and you can add timers that will behave and run an event so that you can create motion or animations in your application. So what we have here is kind of an example of a canvas that's inside of a main window of Tkinter. And the way the X and Y coordinates work is 0, 0 is always to upper left. And the reason why this is because the first 2D or the first gaming technology started out as text that started in the top left hand right or top left hand of the screen and went from left to right, top down. So the X starts at 0 and increases as you go to the right. It decreases as you go to the left. The Y starts at 0 up here and increases as you go down and decreases as you go up. So this 319, the X coordinate is 319 over to here. And this 239, that's the Y coordinate, is 239 down to here. And then this one will be 639 out to here, 479 down to here. And that's all in pixels. It's hard-coded into pixels. And you can change the size of your canvas. However, if you have objects that you're drawing on the screen, you want the size of the objects drawn on the screen to be a proportion of the size of your canvas. You're not gonna want to start out that way. That's a whole nother thing when you actually get into, if you do want to do a 2D game that has some relevance, then you would be doing proportional objects on the screen. So we're going to hard code every object in pixels on the screen for this example. So to create it, we will describe a main window or instantiate a main window within our defined object, and then we will instantiate the canvas with the word canvas here. It could be called anything. It doesn't need to be called canvas. Here is where it's specific. We are creating a canvas object. What is the canvas? Where is the canvas going to be? It's going to be tied to the main window. And then how big is the canvas? It's going to be 200 pixels wide and 200 pixels tall. So a lot of the drawing mechanisms that are allowed in a typical canvas are rectangles, ovals, lines, arcs, polygons, and text. That's pretty much every canvas out there for any kind of high level language has these particular drawing capabilities, and they all work the same way. And they all, they all have similar arguments when you implement them, such as a rectangle always has a location, a width, and a height. A line always has a starting point and an ending point. An oval always, arcs and ovals can get a little tricky, and so can polygons. The main thing that we're going to be working with today, we're not going to work, I don't think we're going to work with text. We're going to be working with the oval. And basically an arc, the oval is a full arc, and arcs can be just partial arcs, and those work with your mathematics library. And you know, you will do things like calculating with pi when you're working with circles. So let's kind of go through an example. Here is where we create the main window. We tie a canvas to the main window, and we draw some lines. Here's the starting point of this line, 0, 0. Ending point is 199, 199. Starting point here is 199, 0. That means here, ending point is 0, 199. Then we pack the canvas totally so that it takes up the middle, is middle justified, and takes up the whole screen of the main window. And then we call the main loop for the main window so that it is always redrawing the canvas as we move the main window around. However, we have the ability to do our own drawing in Canvas, and that's where we're going to be heading into shortly. I don't want to get too in depth here because we're going to be working with this oval. Here's an example of rectangle 2020 that starts here. It goes out 180. This is origin, location, ending location. So origin, width, and height. So it goes out 180, goes down 180, and then it draws the rectangle. And so every time you move this around, it's going to draw that rectangle over and over and over. And then an oval, this has the same starting location, width, and height. It works just like a rectangle, except for instead of a rectangle, it does an arc, a full arc around the, or on the inner boundary of a rectangle's, if it was a rectangle, it would start with an origin and a width and a height, just like an oval, except for an oval is drawn inside of the rectangle. So you can kind of see that it has a rectangle outer boundary and how the oval goes to the outer boundaries of it. So oval and rectangle are pretty much the same. You use an arc if you just want a partial arc, and that's here. Here's an example of an arc, and we don't have to use the math library here. We can use just degrees. And a polygon is a series of points that finally closes at the end. You can see we have 60, 20, 20, 60, so that it begins with the polygon drawing with its boundaries until it closes at the very end. So it automatically closes based on the last endpoint. So you see it automatically closes. So you can do a polygon out to just here, and it will automatically close from the last point that you send it to the beginning point. So a polygon is a series of points that will connect, and the points, a line will be drawn between those points back to its connection point to finish the polygon. I've had guys that have built their own 2D or 3D games using arc and polygon and canvas. I don't know why, but they did. Let's see. Here's an example of putting some text, and you may want to have, like, say you want to keep track of the frames per second. You would want to add some text and update that text every time that the canvas is redrawn, and you would add a timer and tell the canvas to redraw based on that timer. And that's actually what we're going to get into now. We're going to start having some fun. So let's get the initials laid out. And then what we're going to do is we're going to create we probably want to do a floating point value that represents our location. Now, the reason why we want to do that is if we are making like a game and we want to have motion in here, we want to have fractional values of a pixel because we can move an object in between time slices based on that fractional value, even though that eventually when it actually gets drawn to the screen, it truncates to an int. And then that creates smoother motion as you're progressing your not your animation, but your movement through the canvas. So it's a good way of programming a game is even though you are pixel based in the end, your X and Y coordinates you will treat as a floating point value, just so that you can have that smooth motion where in between time slices you're changing the value by just small slices between 0 and 1. And then it truncates to whole pixel values to be drawn to the screen. So we will implement that, and I'll show you a little bit more of what I'm talking about when we actually implement some motion with a variable, with variables in an oval that we're going to drop to the screen. It's time to write some code. Let's go ahead and get the initials set up, and what I'm going to do is we are going to start with a main that's already created and just wipe everything out because our main is now the object itself. Main is instantiating the object. And this is the way Java is based. It's true object-oriented programming, even though Python is object-based. But Tkinter is an object-based library. So our whole main is the object. So what I'm going to do is I'm going to create, first I'm going to need two imports. I'm going to import time. Time we're going to use for movement. So we're going to have a timer that ticks and it calls an event every time it ticks. Say that it calls an event or a function every 5 milliseconds to move our oval across the screen. So we're going to have a timer input or a timer, and then we're going to have our Tkinter library. Okay, then we're going to have our, let's call it game. And we're going to have our init where we're going to declare everything that is part of our game. Okay, now let me zoom in on this a little bit so you guys aren't going blind. Okay, now the first thing we want to do is we want to instantiate our main window. And we can call it whatever we want. Okay, we have our main window instantiated. Now we want to instantiate the canvas for our main window. And you know what? Let's just be a rogue and call it my canvas. Okay, so when we create a canvas, we got to tie it to the main window. And then we have to declare how wide it is, and you know, we're going to hard code this, but this is where I would soft code it to be the size of the display area and open up fully if it's or hard code it so that the maximum size is 800 by 600, and then proportionally change your objects in the screen based on the proportion of the screen size itself, in case the user decides to change the size of the screen. All right, now here's what we're going to have. We're going to have an X and a Y coordinate. Now this X and Y coordinate is going to, what it's going to be is it's going to be the place where we draw an oval. And we're going to start it with an oval. You guys can decide that if you want this to be a true sprite, that you want an animation on. It could be a draw image on the canvas. Possibly we'll look into that, but we're going to work with a draw oval. And what we're going to do is self.x equals, let's just start it out at 5.5. Self.y equals 5.5. This is the beginning of where our oval is. Now you're saying, Mr. B, there is no 5.5 pixel location. Yeah, you're right. It'll truncate to 5. But then we'll add values to it when the timer ticks, and eventually it'll go to 6.3 and truncate to 6 and be drawn at the pixel location 6. So this is just to create smoothness of the motion of our oval on the screen. All right, now here is where I would implement my timer. I'm going to just put this in I'm going to put this in a comment first, and the timer has to be applied to the main window, and let's say that we want it to run every 16 frames. So that 16 value is for frames per second. I think it's after every 1600 milliseconds, I believe. But basically, it's a value that we're assigning no faster than the human eye can see, which is 60 milliseconds or 60 frames per second. And that's when we think about frames per second, 60 frames per second, and how often does a timer need to be called? We're going to pass 16 into it because it's mathematically it comes out to 60 frames per second. And you guys can look into the timer code and how that works to get a little bit more information on how the timer works with what you're doing. We can, look into it later if you wish, but I don't really want to get this video going too long. So that basically ties our timer so that it ticks every 60. So it ticks 60 times a second, which means that it runs every 16 milliseconds or something like that. Not 16 milliseconds, 1600 milliseconds. Yeah, we're going to have to look at how the timer works but we'll get to that later. Let's just get something drawing on the screen and then we can look at timer. Okay, and then we're going to actually call the main loop. Okay, so this is the only thing that this is doing so far is creating a canvas, putting it in the main window, and running the main loop of the main window, which redraws the canvas all the time. So essentially it doesn't do anything. And let's go ahead and do this Python debugger. Okay, and then, it's not doing anything. Why is it not doing anything? Well, because I haven't instantiated the object. My game equals Game, I think, is all we need. Now you notice how this is all the way to the left. It's not part of the object. This is at file scope. So this is like calling main. And all it's doing is instantiating the game so that then this runs and main loop is called and it shows the main window and it redraws it over and over and over again. So when we hit run, main window is going to pop up. Here it is. It looks like the canvas is width and height. We're going to have to do something to set the size of the main window to match the canvas size. It looks like. Okay, we have the start, our canvas. We may not, no, we don't have the canvas in there yet. Yeah, we haven't packed it in there yet. That's actually coming up. So that's why it's not resizing itself. We'll see if it automatically does it here shortly. Let's actually, let's do that right now. I'm looking at some example code of when I did this before. So I think the next step is to just, I think the next step is the timer. Because we haven't packed the canvas yet. And actually, let's try that real quick. Called my canvas.pack. So since we tied the canvas to the main window, as soon as we call pack, what it does is it puts the canvas in the main window, and then when we call main loop, it's going to draw the canvas inside the main window. And it didn't do that before, so it should resize to the size of the canvas, and we should have an 800 by 600 window pop up. There it is. That is 800 by 600. Okay, so now we have our canvas being packed inside of our main window. When the main loop starts, our canvas is being redrawn over and over and over. What are we going to want to do with it? Well, let's say that we want to draw something every 60 milliseconds. So what I'm going to do is I'm going to look at the timer, and we're going to talk about a little bit on this timer.after of 16, and then we're going to implement our game loop. Now, what a game loop is for a game is it always does two things. So our game loop we're going to actually put up here, and I'm going to just throw in def game loop for right now. And we're going to throw in a few comments. What a game loop does is it always gets input from the user. You either keyboard, like you're pushing a key and you want to move something. It's always processing that input. It's saying, hey, move this thing to the left or the right. And then what it does is it updates. It updates and redraws what we're moving to the left or right, depending on our input and what we've processed. And so what process it does is it changes the X and Y value of what we're moving based on the keyboard input. And again, we'll see how far we get with this toying around. I'm going to, when we come back, we're going to implement the game loop to run every or we're going to implement the game loop to run 60 times a second. So it's going to be we're going to implement that so that's 60 frames a second. Essentially, basically as fast, We don't need it to run any faster than that because the human eye can't comprehend any more than 60 frames a second. So there's no reason to update, process, and redraw more than 60 times a second. So what's going to end up happening is, just like this, every time we move the canvas in the main window is being redrawn, we're going to have our own game loop that redraws information that we're going to put inside of this canvas so that it redraws 60 times a second, so that we can have something moving across the screen that we can visually change and process and then update and create motion. So that's what we're going to do when we come back. I'll see you guys shortly, and we are going to implement our timing, our game loop, and start really having fun. All right, see you guys in a little bit here. I will be back. Okay, guys, we're back. So the timer is as I thought. It works just like every timer out there. It works based on milliseconds, and the argument you send it is how often it is called every millisecond. So what that means is that if we have a timer that calls a function and we tell the timer to call itself every 1,000 milliseconds, it will run every second. And what that means then, if we want a game that runs 60 frames a second, we need to have it run, we need to pass, we need to take 1 second, divide it by 60 for 60 frames a second, and we get a frame rate or a timer call of every 16 milliseconds. So that means that our game update needs to happen, our game redraw, our game loop needs to happen every 16 milliseconds. And that's what that 16 value is for. So let's play with that and implement it with just every second first. So what we're going to do is we have game loop defined up here, and we're going to tell the main limit window to update every and what we're going to do is we're going to have this code. We're going to tell the main loop or the main window to call the game loop function every second. Eventually we're going to turn that back to 16, where I'm just going to show you how it works every second. So that's where we're headed. And what do we want to do in our game loop? Well, in our game loop, we're going to want to draw an oval and just make something move across the screen. So this function is going to be called every second inside of the main window, and the main window is for our game object. So let's define our game loop. And the first thing that we're going to do is we're going to iterate and change the X and Y values. And we're going to draw an oval based on the X and Y values. So let's go ahead and do that. So when our game loop is called, we're going to, and you know what? Let's just do our oval first. So we can access our canvas using the self method. Oh, we got to tie this to the object with self so that it has access to the canvas. We say self.canvas, and then here's where we're going to do create oval. Create oval, and we say self.x. Now, we're going to want to probably specifically cast this to an int, because we've declared it as a float with that 5.5 value. And then we're going to have the oval start at also drawn at the Y place. Cast that to an int. And then we're going to say, hey, how big is the oval? Well, let's just make it, the oval needs to take and let's get on the whiteboard here. Oh, come on. Get out of there. All right. Here's our main canvas window. Let's say that we start our oval at X here, and we tell it to draw 20 out, and 20 down. So that means we need to start the drawing at X and end the drawing at X plus 20. And Y plus 20. So we say start at X and Y, and then draw out to integer of that plus 20, and this self.y plus 20. And whoops, we've got to actually close that. So that's telling the canvas in the main window, the canvas in the main window to let's go back up to it, to draw an oval starting at location X and ending at location X plus 20 and Y plus 20. Starting at location X, Y, plus 20 plus 20. So that'll draw an oval 20 by 20, so it's a circle. And let's look at it. We haven't really done anything like describe colors, and that's fine. We don't need to get into that. Okay. It looks like I've got an error here. It doesn't like me for some reason. It might not like my conversion. You know what? We're doing too much at once. Let's just get the after working first. And let's comment this out for now. And what we can do is we can just say S equals whatever here, just as a placeholder. Let's see that, make sure that this line of code works first. Only if it just, it runs. Oh, that's why. Look at that. I added an extra thing in there. That's why it's not working. Okay. Yeah, that happens. Okay, there. Good. All right, now let's uncomment this and get rid of that. Now we got another issue. Oh, that's because I didn't close it. It closed down below with the syntax error. So that should work. Okay, let's run it. Okay, we got problems. We do not have the oval running. Interesting. Okay. Let's do this. Let's comment this out. And what we can do is just do the, oh, I know why. I said canvas here. That's why it's white. It's my canvas. Gee whiz, I should have gone with just canvas. Getting cute. Okay. Are we running? Still not running. Okay. Oh, wait. We got to wait a second. There it is. Boom. There is our circle. Cool. Now I'm sure, we can decide how we're going to do this circle later. Actually, I don't even want to go down the rabbit hole because I would actually make this an image. And that's the direction we're headed eventually. So let's get some motion of this oval, the circle. And we're drawing the oval every second. Let's move the oval and draw it. So after we draw it, let's do this. Let's say self.x is equal to its current value plus 0.5. And so that way it moves one pixel every 1,000 milliseconds. Because remember, that function, the game loop, is only called every second. And if we're moving it half a pixel every second, it won't move a full pixel and show it until 2 seconds has elapsed. Okay, so when we run this, and game loop is first initially called, it will draw at location 5 and 5, because the 0.5 will be truncated. Then we will move x and y by 0.5, and when it comes back after a second and redraws that, it'll go to 6 and it will move after a second. Yeah, it'll move after a second. And then it'll take 2 seconds to move again. Okay, let's run it. Okay, so wait, runs 1 second, it moves. Oh, I'm a liar now. For some reason, let's hit a breakpoint here and see what's going on. Oh, that's right. I know why. It's beautiful. Okay, this is great to discuss anyways. What this line of code says is run the game loop function after a second has elapsed. We have to call this again at the end of game loop, so it calls itself again. So this is the update and redraw. So it updates and then redraws, updates, redraws, updates, redraws. So that's what we're missing, was to say after a second, call the game loop again. Here, when we start the init, we call the initial game loop, the initial call to game loop, and then from there on out, game loop calls itself. And the reason why this is not recursion, because we are not winding the stack because we're using a timer. The timer is a side process that will call it, but it's not tunneling a hole or winding the stack. It's another, you can think of it as another thread. Okay, there it is. It moved. There it is. It moved again. It moved again. It moved again. Every 2 seconds it's moving. Let's get that faster. Okay, let's do that 60 frames a second. And what we're going to do is we're going to put 16 here for 60 frames a second and 16 here. So it's going to be called every 16 milliseconds times 60, which is about 1,000. So 60 frames a second. So this function is going to be called 60 times every second. Whoop, there we go. We're moving across the screen. But you're like, oh, Mr. B, why are we getting a line? Well, the reason why we're getting a line is because we're not clearing up our previous draw. We gotta clean it. We gotta scrub the canvas so that our update is a true update instead of, we gotta clear the previous draw off of the canvas. So what we gotta do is we gotta tell the canvas to delete itself so that our next draw happens. And this is how we'll do it. We'll do it at the very beginning of the game loop. And what we'll do is we'll tell the canvas, and you can tell the canvas to only delete specific areas to clear itself in specific areas. If you want to improve the behavior of your game loop so that it's faster, instead of clearing the whole canvas, you could just clear the area that represents an image that you're animating. So you're not blinking out the whole canvas. You're only doing a part of the canvas. And that's how you would, get it so that your drawing was a little bit more efficient. Well, we're going to just go ahead and do all of it. So we tell it to delete all. And what that does is it just basically clears out the canvas and all its drawing. And then we update here. Here we clear and we redraw from the previous update. And the order in which you do these things matters. Because you could actually get it so that you do it in the wrong order and you don't see anything. So now we're going to run this. And there's our circle moving across the screen. But it's a bit slow. So here's what we can do is we can start adding some motion, some physics to this, and maybe some wind, some gravity, stuff like that. So let's go ahead and actually do that. But first, let's define a special function, because here what we're doing is, you see this constant? This is the change, the value, or how much x changes every time through the game loop. This represents the speed of our object. And we call that delta x and delta y. And it's also our velocity value. So what we're going to want to do is we are no longer going to want to assign, we want to assign x to a starting value. Let's just assign it to a starting value of 5.5. That's fine. But when we update x, we don't want to update x and y with a constant. This is a constant. We want to update x and y with a variable that we're going to call velocity. And so we're going to say Vx equals 0.9. Self.vy is equal to 0.9. That means every frame it will increase by 0.9 of a pixel. So that means it's not going to change every frame. Only when that truncates over to a full pixel as it's progressing through its values will it actually update. So now when we update, we are no longer going to update based on this hard-coded 0.5. Now this is going to be based on self.vx and self.vy. And then we can change the Vx and Vy and see it's kind of a little bit faster. Well, what if I wanted this to move just down? Okay, so then I could assign Vx to 0.0 and Vy to 0.9. And you see it's just moving down. What if I want it to be like a slope like this? Then I can reduce and just assign Vx to 0.2 and Vy to 0.9, you see how it changes the slope? It's really cool what you can do when you get into this stuff. Yeah, you can have a lot of fun, and so let's continue having some fun. Here's where we get into where we can make some changes before we add physics to this with acceleration. Let's make it so that we have some collision detection so that our ball is bouncing off the screen. And that means that we need to reverse its direction of movement. And if we want it to go backwards, we subtract X or Y. So that means that if we want to move in an opposite direction, we just make Vx a negative value, and then it moves backwards. Or Vy a negative value, and it moves backwards. So when do we decide to move negatively? Well, let's say that if the ball gets to the farthest edge of the screen, then we want it to bounce and come back. So here's where we are going to add an if statement. If self.x is, if it's gone to the left of the screen, if it's less than 0, or self.x is greater than 800. And guys, we want to actually end up adding the velocity so that we want to add velocity to this so that we don't have too much of it getting caught in the edges, and that happens. But I'm just going to make it simple for now so you can visualize it. Now, if our x value goes all the way off the screen this way, or our x value goes all the way off the screen this way, we just need to reverse its value, whether it goes positive or negative. So that's when I will do this. I will say self.x or Vx is equal to self.Vx times -1. Okay, and then what we're going to do is we're going to just test this by having our velocity of y be 0, and let's go rather fast. Let's go 1.9. 1.9. Let's move really fast for Vx, and then when it gets to the edge outside of the screen, it's going to bounce back, and when it gets to that edge, it's going to bounce the other direction. Okay, there we go. We're moving to the right. Bounce. Okay, and then the next one is coming. Bounce. Okay. Now you see it kind of went off the screen a little bit on this bounce. We could put a size of -20 offset here so it doesn't go 20 pixels off to the right. But let's not complicate it. Okay, we can do the same thing with y. Now y is 600 tall. Okay, now let's have some real fun. Okay. Yeah, we're ready. Whoop, whoop. There we go. Whoop. Okay, now let's get crazy. Let's add some wind and some gravity to this. And then I'm going to leave you with an extension and an extra credit assignment. I will describe the extension here in the video, and I will describe the extra credit on the assignment page. Let's go ahead and do this. All right. Now, acceleration is the change of the x and y, delta x and delta y. So that's like a car that's moving if you have the gas pedal always at the same level. It's a constant speed. But what happens if we want to speed up and slow down? So acceleration is the change of location, meaning you're accelerating, you're moving, not accelerating, your velocity is moving constantly. What acceleration is the change of your velocity. So velocity is the change of your location. Acceleration is the change of your velocity. Acceleration is the change of location. Velocity is the change of your location. Or acceleration is the change of your velocity. Just like you can have your gas pedal constant, you can hit the throttle real quick to speed up and go back to constant speed, or you can come off the accelerator to slow down. So the velocity is the change of location based on a constant. Acceleration is how much that velocity changes as you step on the gas or come off the gas. And that's where the physics happens. Now here's the key of actually making the physics work. Between slices of time, your acceleration has to go to zero. Because when you think about it, if you're moving and there is no time, there is no acceleration. And that's the secret. Let's implement it. So now we're going to go down here and we're going to say Vx and Vy are always dependent on acceleration. Self.ax equals 1.9. Self.vx is equal to self.ax. And ax is acceleration, vx is the velocity. Self.ay is equal to 2.9. Self.vy is dependent on self.ay. And location is dependent on your velocity. Now these are just starting values, so they don't really matter. Basically everything that's really matters is what's going on in your game loop. That's where the magic happens. So here's what we're going to do. This is the starting of our movement. And what we have to do is X and Y are depending on Vx and Vy. Vx and Vy or Ax is equal to self.vx, self.ax plus self.vx. So that's how, the acceleration, Ax, what we're saying is its current value, oh my goodness, I'm even confusing myself. Yeah, I did this wrong. Vx, the acceleration of Vx is dependent on its current velocity plus if you step on the gas. Self.ax. Self.vy is dependent on the current velocity of y plus if you step on the gas in the y direction. And then when we add acceleration, here's the thing, is that when you're done with the acceleration, each time your acceleration has to, there's a point where acceleration has to come down to 0, because you'll see what I'm talking about real quick. Because what will end up happening is, if this thing is called 16 times a second, it's like you're always stepping on the gas. We're just full throttle. So let's do a few modifications here. Let's start our acceleration at 0. And then our oval will start at location 0, 0. And then each time through the loop, our acceleration is going to be constant right now. So let's just run that and see that we got something that's behaving. So we got a 0, 0. It's doing nothing. That's fine. We may end up getting stuck in here. Oh no, if we started at 0, it's going to be, we're looking at less than 0, so we're fine. So how does our motion actually end up happening? Well, we're going to start with a static Vx and Vy. So let's do this. Let's do 1.9 and 0.5. So we're going down and to the right, kind of like in that direction. Okay, and remember, this is just initial values. But what if we want to speed it up? We can add acceleration here if we want to speed it up. Right now it's constant. So let's go let's do this. Okay, there, it's constant. So let's say that wind is blowing on this circle. We have wind blowing on it. And what we want to do is we want to add that as acceleration to the wind blowing on our oval. And that means that our acceleration is going to be added to our velocity. And our velocity is going to increase over and over and over again until it reaches a threshold where we tell it to decrease. And we'll put a limiter on it. But let's look at the crazy first. So let's say that this wind is going to continually blow on this to the right. And so that means that we're going to add a force, a wind force to it in the form of acceleration. And our acceleration is going to be added to our Vx and our Vy here. So this is where we actually add the force to our velocity. So then that means that we need to define our wind force. So this is going to be our wind here. This is our wind section. Let's blow some wind on this guy. And what we're going to do is we're going to say every time in the loop, we're going to blow some wind. We're going to blow 0.02 amount of wind to this. And that means then our velocity, our acceleration for y is going to be 0 because we're only blowing to the right. But what if our wind was going like blowing to the right and down? We can add a smaller value to it so that our wind was blowing to the right and down, so that every time through our game loop, we add a little force to the movement or the velocity of that oval. And you're going to see the crazy here because it's just going to continually to get faster and faster until it reverses direction. Then it's going to slow down, and then it's going to go over here, and then it's going to bounce, and then we're going to blow more on it, and it's going to speed up. And this is where our physics go in. It's going faster, 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 faster. Bounces, slows down, slows down, slows down, goes down. Okay, well, that's not very apparent, is it? Let's make it more apparent. Let's add a 0.1 here and a 0.05 here. Okay, now it's going really fast. Woo! Then it blows against it, slows it down. Now it's going really fast. Blows against it, slows it down. Now it's going really fast. Okay, cool. Let's make it faster. Now it's blowing, going down, blowing, slowing down, going faster. Isn't that cool? It's a lot of fun. We are missing something that we should be doing here that we're not doing. And that is every time through this loop, we should actually be zeroing out X and Y, the acceleration. So every time through, we need to actually be down here is zero out AX and AY. And then what we're going to do is we're going to make this a little bit more dynamic. Okay, so because AX and AY, the acceleration should be computed based on the prior acceleration and the prior velocity. So we're actually not doing the algorithm right for true acceleration. This should be self.ax, the previous velocity plus the new velocity, self.ay, previous velocity plus the new force, the new wind force. Because your velocity, if you're stepping on there or if you're blowing against an item and it accelerates in speed and you continue to blow, it's going to continue to accelerate based on its previous acceleration, and the velocity is going to change based on its previous acceleration. So this is actually the way you want to do it. And this is where the crazy comes out. Because we are forgetting something. Look at that nut. That it just goes to crazy real quick. Because we are not taking an advantage of the time when there is no time. When there is no time, there can be no acceleration. So at the very end of our update, our time update, we must change our acceleration to nothing. It's got to zero out. And so then the acceleration zeroes out for when it's between time. When there's no time, acceleration is zero. And then velocity is added to based on the acceleration. And now we have a proper physical algorithm for applying physics force to our oval. And I got a border collie that's yelling at me. Okay, now it's working a little bit better. Don't bark at me. Okay, let's add some gravity to it. When I come back, I got to take her out, and I'll see you guys in a little bit, and then we're gonna be done. Or I'll let you know what your assignment is. Let's see here. Okay, I'll see you guys soon. Okay, we're back for our last jog around on this thing. Here's what we're going to do. We're going to, this would be the wind force right here. This could be both wind or gravity. What we're going to do is let's make it so that it's a huge gravity. And you know, you could do separate forces both for X and Y. You know, this could be, let's say, the wind, and you know, it's kind of, you know, maybe there's no gravity, and then down here you put gravity where there's no wind. You know, so I guess when you're applying forces, you got to think two-dimensionally, of course. This would be no wind, with gravity, or you could just put them together. And this is kind of, you don't really need to assign them, and we can just put wind and gravity together by doing this. But you can have separate forces that act two-dimensionally on this. In this case, we're combining two forces to the same acceleration addition. And this would be gravity running. So let's go ahead and run this. And you kind of see the behavior balances. You see how it's kind of getting lower and lower, lower. It's looks like it's accelerating. It's not really getting low enough. Oh yeah, it's getting down every little bit. The gravity's kind of coming down, and eventually it's going to get down to nothing and just be along the bottom, kind of stuck. Yeah. Oh, there, it's stuck. We have went off the screen. So what you would do in that case is, the reason why that's a problem is because these if statements get it kind of stuck off the screen. What you would want to do is you would want to offset with your velocity here, so that you take in consideration both the size of your object and the velocity as an offset in your if statements. And then that would fix a lot of that collision problem with your object actually going through your wall, because it kind of gets stuck between these if statements if you don't take in consideration the velocity as part of your algorithm for making it bounce. But that's something that we don't really need to get into. You would do something like plus self dot bx or something like that, so that you're taking the velocity into consideration in some way in your equation there. And yeah. So here's where we're going to be at. Let's just take one last jog through all this code. It looks like, yeah, we didn't need time because the after works just fine as part of the Tkinter timer. And let's just kind of go through it all here so you guys have a snapshot of all this code. And that way you can reproduce it. Get it kind of all together. Give you a good look at that. Then we're going to go down. We have our if statement. We zero out our acceleration. We don't really need that. We blank out our canvas. And this is where we initialize everything. And then, default values for our acceleration, velocity, and location. And then we get the first call to the game loop, which then will call to itself from there on out. And this is what, gets it actually beginning from the init. And this is the first call to the instantiation. So here's what I want you to do as for your assignment. What I would like you to do is, if you want to take this as your alternate assignment, add another 4 objects moving around. And those 4 objects could be where you just create a AX1, AY1, VX1, VY1, self X1, self Y1, and then do the same thing for 2, 3, 4, and then you have 4 of these lines of code, 4 of these where you're calling X1, X2, X3, Y1, Y2, Y3. So basically you just duplicate this all so that you have 4 things move around, 4 ovals moving around on the screen. Maybe play with it by doing create a rectangle instead. But, add that in for your assignment, and, further instructions I'll have on the page. It was fun. We're going to continue with this in the next video. So see you then in our next module. All right, guys. Have a good one. Thanks. Goodbye.